Let's solve this problem. They have given that it is a byte addressable system. See, whatever we have seen so far, everything we have assumed that it is a byte addressable system. What does it mean? In case if we have a RAM, every byte of our RAM will be given an address, which is nothing but physical address, right? Similarly, when we consider process, every byte of a process will be given an address. We say that as logical address. Fine. We have one more thing called as word addressable system, which we'll see that a bit later. Okay. As of now, let's assume that it is a byte addressable system, and they have given that logical address space equal to 256 KB. Now I can convert this in terms of powers of 2, right? It will be easy for so it is nothing but 2 power 8 into 2 power 10 bytes, which is nothing but 2 power 18 bytes. Similarly, physical address space equal to 1 MB, which is nothing but 2 power 20 bytes. And they have given page size equal to 4 KB. 4 is nothing but 2 square into 2 power 10, which is nothing but 2 power 12 bytes. Okay, so they have given page table entry size equal to 2 KB. Now they are asking all these questions. Okay, we need to answer them. Number of bits in logical address. See, number of bits in logical address really depends on logical address space, right? In logical address space has 2 power 18 bytes, and every byte will be given an address, which means we need 2 power 18 addresses, right? 2 power 18 binary addresses. Now in order to generate 2 power 18 binary addresses, we need 18 bits. So logical address, number of bits in logical address is nothing but 18. Now what is the number of bits in physical address? That really depends on physical address space, right? Since we have 2 power 20 bytes and it is a byte addressable system, the number of bits in physical address is nothing but 20 bits. Number of bits in page or frame offset field. You know what is meant by page or frame offset, right? See, let us assume I'm taking physical address. Okay, this is physical address. Physical address will have frame number and frame offset. We have calculated, this is physical address, we have calculated physical address to be 20 bits, right? Overall it is 20 bits. Now what is the frame offset field? That really depends on what is the size of a single page, right? Page size, if page size is equal to 2 power 12 bytes, then frame size will also be 2 power 12 bytes. Now in order to address 2 power 12 bytes, we need 12 bits, right? So frame offset field is nothing but 12 bits. Frame offset field. If frame offset field equal to 12 bits, then page offset field will also be 12 bits. So if this is 12 bits, then this will be 8 bits, right? So number of frames is nothing but 2 power 8 frames, right? We have 2 power 8 frames in our RAM. So number of frames is nothing but 2 power 8. Now how to calculate the number of pages? That really depends on logical address, right? See, coming to logical address, we know that it is 18 bits. Logical address equal to 18 bits, and page offset field will have 12 bits, which means page number field will have 6 bits. Okay, so if we have 6 bits in our page number field, then the number of pages is nothing but 2 power 6. So there are 2 power 6 pages in our process. Fine, now how will we calculate the page table entry size of a single entry of our page table? That really depends on the number of frames, right? See, frame number field has 8 bits. If there are 8 bits, then every entry in our page table will have 8 bits. Why? Because page table entry is actually indicating the frame number, right? Frame number in which the corresponding page is present. And so if frame number field is 8 bits, page table entry size will also be equal to 8 bits. Now what is the size of the page table? See, page table is nothing but it will have number of page table entries, right? So page table size is nothing but number of page table entries into size of a single entry. Number of page table entries is nothing but number of pages, right? Because for every page we maintain a page table entry, and so number of page table entries is nothing but number of pages, which is 2 power 6. So 2 power 6 entries size of a single entry really depends on frame number, right? Because in every page table entry, we actually maintain the frame number in which the corresponding page is actually present. And so page table entry size is 8 bits. 8 bits per entry, right? Why? Because size of a single entry is nothing but 8 bits per entry. Okay, the unit is bits per entry. Now entry and entry will get cancelled, and so 2 power 6 into 2 power 3, which is nothing but 2 power 9 bits is the answer. 2 power 9 bits is the size of the total page table. Okay, in case if I want, I can convert this into bytes. How? I can divide by 8. So 2 power 9 divided by 2 power 3 is nothing but 2 power 6. So 2 power 6 bytes is the total size of the page table. Fine.